I'm Mikayel, and with my colleague Rafal, we're going to present you the recent enhancement that happened to and new features in import and export in Wolfram language. We'll show you how the workflows involving the files are now even more efficient than ever. We're going to cover richer metadata and partial access in Wolfram language. And last but not least, we'll talk about the recent enhancements that happened to scientific format support in Wolfram language, such as FITS and HDFS. And my colleague Rafal, we're going to present you some enhancements and some new features in the import-export in the Wolfram language, and also show like how the workflows that involve files are now even more efficient than they were ever. We'll also cover things like partial access and more powerful metadata support. And last but not least, we'll talk about enhancements that happened to such things like scientific formats, for example, FITS or HDF5. Before jumping into that, let's start from something new, which is convenience function that we introduced in version 12, which is called FileConvert. So what it does, it's currently kind of a very simple function that basically converts from one function, from one format to another format using the import and export functionality in the Wolfram language, but eventually this should be a smart enough function to do the conversion without actually manipulating with data. So finding out the smart ways to convert from one format to another format. So what it is right now is basically you are able to convert, for example, a JPEG file to a PNG file, and you will get this as a wrapped into a file wrapper. And just to show you that as a result of conversion, the results should conform, and basically there should be no difference in the original image that was stored in JPEG file and the resulting image that is already a PNG. This is the basic syntax that is supported, but there is some extension. For example, you can specify the exact file name that you want to be converted to, or you can even specify the formats that you want to convert from and to. So for example, like this JPEG file, we say that this is going from JPEG to PNG, and it doesn't really make much sense for this particular example, but where it can be useful, for example, we create a file, and this file contains actually a CSV data, but this is stored in a TXT. So we now can say, okay, let's convert this TXT to something else, but we know that there is a CSV data, and we actually want to have a TSV as a result. And this will basically work. So the new file that we get basically is a TSV file. And there are some options to help you to play with this function. So one of them is this create intermediate directories. It's basically if you try to convert to a location that doesn't really exist, it will try to create the location by default. But you may specify it to be false, not to do so. So basically, if I try to create something in a directory that doesn't really exist, it will not allow me. And another interesting thing is OverwriteTarget, that by the default, it will basically overwrite the original file if it exists and replace with a new converted one. But you still can say, okay, if there is something that I already created with that name, just don't do anything. So you say, do not overwrite target, and it basically will fail. So, but this OverwriteTarget is kind of something new, and let's basically see what it is. And I think Rafal will basically tell you a bit more about that.
Right, yes. Okay, so you may recall that in Mathematica 11.3 and before, export would always override the destination file, right? So, for example, if I export hello to a text file, then I export world. So if I import this file, then I won't get hello world or anything like that. Oh, yeah, I think it is, but
it's better now.
Okay, I will speak like this. All right, so yes, the export would always override the destination file, and this isn't a perfect solution.
Mic's not working. Just hold it in your hand.
Okay, maybe I can. Okay, I can hold the mic. All right, so this isn't a perfect solution because it's easy to lose data by accident, right? If we forget that we already have have a file, then it will be overwritten. And also, it's not possible to perform a complex multi-step export, right? So, for example, for a GIF file where there are multiple frames, it makes sense to be able to export frames separately, right? So that we can append new frames at the end of the GIF file. Right now, this is not possible. So that's why we have introduced a new option to export, OverwriteTarget. And there are 3 possible values for OverwriteTarget. The first one is true, so this is the default value because we want to be backwards compatible. So this corresponds to the current behavior. But now we can also specify false. So first, if the destination file does not exist, it will be created. And then if you try to export something else, you will get an error message. Okay, and the last possible value for OverwriteTarget is append. So this is not supported by all formats, right? Not in every format it makes sense to append data. But one file format that supports it is HDF5. So in this example, we first export 2 groups to an HDF5 file, right? Well, there's also the root group, which is always there. And then we want to add a new group to the existing file, group C. So we use this OverwriteTarget append, right? Okay, let me scroll it. Yes, so now you can see that we have a new group and those that were there before. Okay, so this is OverwriteTarget. Let's now talk about an update to import, namely partial access. So imagine you have a very large set of data and you want to access only a small part of it. So it does not make sense to import everything, load everything into memory and then extract, but it's better to just import specific parts from the file. Here we have a CSV file, and we can say that we want data, and let's just import every third row, starting from the second one and up to 12. Right, so this will import exactly what we requested. And you can see here that I can basically achieve the same thing by first loading everything and then doing part, right? Yeah, so the result is the same, but for large files you will notice the difference in speed, right? So we can go even further and first specify the rows and then columns from a CSV file, right? So this will import only contents of the second column in those rows, right? So we can see that this is actually this. Okay, and for CSV and Excel, and this topic will be covered in details by Sean in his talk, which is right after this one. All right, and we have another way of doing partial access. So you may have a large piece of data in your file and then a small pieces of metadata. So again, it makes sense to be able to import this metadata very quickly without loading the whole file. For example, I have this 2 gigabytes HDF5 file, yes, with plenty of real numbers. But you can see that if I want to import just a list of data sets, it happens instantly, right? Same for the data format. All right. So let's talk a bit more about partial access in case of HDF5. Because in general, our ultimate goal is to have a consistent syntax for all formats to do partial access efficiently. But right now for HDF5, the syntax is a bit different. We have an option called take elements. And for example, let's work with this file. Yes, so we export a matrix that looks like this. So there are 3 ways to access specific parts of this data set in HDF5. So you may give it a list of positions, right? So for example, let's say I want to only import cell 1, and 2, 3, which is this one. It looks like this, and I get 1, 5. So this works, and it actually works pretty fast. Let's do a test on this 2 gigabytes file that I had on a previous slide. So now if I use take elements to import just like 5 points from this very large file, it happens instantly. So the second number is the number of bytes in the memory that were used. And just to compare it, let's import everything and then use the built-in function extract to get the same points. And you may see that it's like 2 orders of magnitude slower. Okay, another way to do partial access in HDF5 is to specify spans. So this is quite similar to what I showed for CSV. So here you see that, here you say that you want rows from the second to fourth and columns 3 to 6. And if I'm not mistaken, this should be exactly this rectangle here. Let's see. Right, okay. And the last thing is that the last syntax possible is that you can use those 4 like sub-elements. This is a native way of doing partial access in HDF5. Well, instead of describing, let me just show an example. Okay, it's quite large. So imagine this grid is a data set. Each cell is a one piece of data. So, and the blue region is what we will actually import, right? Which data elements. So offset means where do we want to start importing, because it doesn't have to be at the beginning. Then we, of course, may want to import many data elements, but it doesn't have to be a contiguous region. So we may want to have gaps, right? So this is stride. And up to this point, it can be achieved using those span syntax above. But now, let's say that we don't want to import just one cell in every block. Yes, we can import more cells, right? So something like this, quite complex, it can be achieved using this last syntax. Okay, so this is partial access in HDF5, but there are other new elements. So in export, you can now export data sets. So these are just containers with data. You can either give it just data or data plus some metadata, right? And this is imported back. You can export groups. Either just give it a group name, or you may have groups with some links. Okay, and you can import the file as a graph to see its structure, and you can see the 3 groups we exported and those links that we defined here. Another new element in export is named data types. So we can basically have an information about some type, either very simple, like unsigned integer 16, or something more complex. And you can save it to a file and then import it back. Okay, and the last new export element is attributes. So every object in HDF file may carry attributes. So these are basically pairs, like a name and a value, which can be of any type. Here's a string, here is a byte array, because why not? Okay, and we can import that back. All right, so apart from export elements, we now support more data types in data sets. So we already supported integer and real numbers. Now we have complex numbers. Although they are not natively supported in HDF5, we have an option called complex keys, so that you can help export to how to save the data in the file. And then we can import this back as complex numbers, right? So this is the data we exported and the type. And also now we correctly support UTF-8 strings in HDF5. There is also another new type. It's called opaque in HDF5. This can be used for data that does not have any predefined meaning. So this basically corresponds to byte array in Wolfram language. Yes, for example, here I have a hash of some string, which I export, and then I can import it back as a byte array. Okay, and the last one, the most complex type, is called compound. So this is like a map of key value pairs, and this corresponds to an association in HDF5. So the values can be of different types here, like a list of integers, a string, or you can have nested associations. All right, and you can see that we can import it back from the file. Okay, another new thing in HDF5 is a new option, AppendMode. This is basically an extension of this OverwriteTarget that I talked about earlier. So now if you export some data to an HDF5 file, like a data set, a group, an attribute, you have now three possible ways of appending new things to this file. The default one is extend, so you can add new data sets to the file. You can add new features to existing objects, for example, new links in a group. And as you can see, we added a new data set and a new link. So then if you want to modify existing features of existing objects, then you have to use overwrite. So now you can take this link, gr1, and redirect it to a different object in the file. And this will completely change the structure of the file, so you have to be careful. You can also override the data in the data sets as long as the data format and dimensions match, right? So I have a data set with a list of 10 integers. I can basically overwrite it with a reversed list, right? Because the data type is the same. And there's also last possible append mode. This is the safest one, preserve. So here you can only add new objects to the file, but you cannot touch anything that already exists in the file, right? So I can add new data set, but this should trigger a message. Let's see. Right, okay, so I cannot modify the existing group, but I was able to add a new data set. All right. And there's also one last update to HDF5. So now we directly support numeric arrays in HDF5. So a numeric array is a new container that we introduced in version 12. It's basically a more memory efficient version of packed array. So just to show you the difference, if we have a million integers in a list, it takes 8 million bytes, but with numeric array, if we say that those integers are all quite small and they will fit in with 8 bytes, then you can see that it takes less space. All right, so let's define such a numeric array. And basically, there will be a separate talk devoted to numeric arrays. It's 2:30 p.m. I really recommend that talk. Okay, but back to HDF5, you can see that I can directly put a numeric array in export. It will be exported, then I can import it back. Here you can see that the type of data is actually taken as this one. All right, so as for import, we have a new import element, raw data, that it will everything that is possible will be imported as numeric array for efficiency reasons. So let's just quickly compare the timings. You can see that if you can live with numeric array, then it will be imported much faster, and also with a smaller memory footprint. Okay, so these are all the updates to HDF5, and now let's talk about fits.
Okay, so fits is another scientific format that we support, and we did introduce this earlier, so this is not new in 12, but there are some kind of important highlights that I would like to talk about. So first of all, one thing that is new is now that everything is returned in form of associations, even if you have a single HDF file, which was not the case before. And even if you specify, that you want to import specific header here, even in this case, this is going to be association. And this is kind of very useful thing, because when you say you have a multi-header file and you want to import only image data, the distribution of the headers containing image data can be not continuous, and you may get first thousands and 5,000s are images, and if you get it back as a nested list, it's kind of hard to figure out who is who. And this way you always know which header is correspondent to which part of the data that you imported. Another thing is that we have basically changed the default behavior of an option that was supported, which is IncludeExtensions. And basically, what it was before, it was importing everything that is present in the file. And now it imports whatever is related to the data that is requested. So for example, if we ask for table data, and this is the default behavior now. So the second header of this file contains the table data, and that's imported. So you can't see the first key in this association. While you still can trigger the legacy behavior by specifying IncludeExtensions all. And of course, the same things that were supported, like list of strings as a value for IncludeExtensions, is still supported. Another thing, as Rafal said, for example, for HDFS, the raw data, this is very well valid for fits as well. So we have NumericArray support for image data because it doesn't really make sense for tabular data in fits. And this is very well supported in export of fits as well. I'm running a bit out of time, so that's why I'm going this quick. So the other thing is that people who are more or less familiar with fits may know that binary tables are kind of very complex structure in fits, and they are always two-dimensional, but each cell can be multi-dimensional. And we did support import for that type of binary tables, but now we also do have support for export of that type of tables, which opens up, like possible applications for this case. I will show one at the end. And of course, partial access is very well supported for fits as well. So what we had, for example, this header specification before. What we added, basically, we added a full support that is supported by part. The same syntax is supported for partial access here. So you can basically use spans, lists, and so on. Okay, so besides being able to specify the header, you are also able to specify partial access for the actual data. So this is how it works. And the beauty of partial access in fits is that in image headers, you may have, like arrays up to 999 dimensions, and this is a way basically not to deal with all of that memory. And if you know what exactly you're looking for, you can easily get that back. Of course, this is efficient. Of course, this consumes less memory. I mean, even for this file that is really small, you can see the difference both in timing and the memory consumption. So this really makes sense. And as I promised, the application that, okay, so I can say that we have kind of complete support for fits, and this opens up a lot of possibilities to create, like real-life working application examples. So for example, this is one thing that I've prepared for today. So you basically are able to select the directory where you have all of your files that you're interested in and load them to the memory. And basically you have this type of list here, basically, which contains all the file names you are looking into. And for example, you can click on any of them, and on the right panel you will see the detailed header information and also the data. And for multi-table, let me see. Okay, so for example, here we have 2 HDUs here, and you can basically trigger between each of the HDUs, and both image and table data are present here. And what else you can do is basically since like you may want to use this in another application, for example, you may trigger a download to basically convert this to more widely used formats and download this file. For example, I can do this on my desktop, and you will see that this file, for example, is or should. Okay. Yeah, so basically it's converted to TIFF. So this TIFF contains now the actual image what was stored in the fits, and basically the meta information is stored in XML. So looking up this XML doesn't really make much sense here. But this is how it looks, and you can basically inverse this back to Mathematica. And another cool thing that you have here is that basically you are able to do really quick search, which is basically almost instant. Is say, for example, you can basically search for all the files that you have that are the organization that made that files, for example, ESO, and I may not have that, okay, but okay, maybe we can find the ones that start with M. all the object that contain. Okay, so this file contains an object that starts with M, and you basically have. This is just a like demonstration application. You may enhance in whatever range, and the purpose of this is to show that the support is full enough to do any real life application with Mathematica now. Okay, so where is that? And that's basically it. So if you have any questions, I think we can answer them. In the meanwhile, the next speaker comes to. Otherwise, yeah.